All right, so they are satellite dishes. I think they are shaped like dishes because of how the communication is between them and the satellite. Okay, that's pretty good. The satellites, and I think they're shaped like a ball, so they can catch more energy. Okay, good guess. Wi-Fi things. Okay, it's not wrong. A type of antenna. I think they are shaped like dishes because it helps catch what they can hear. Okay, okay, good guess. The satellites, they're used for sending signals. They're satellite dishes, they're used to receive waves from other satellites. Okay, that's a really good one. I think they shape like dishes because to reflect the signal. Yes. Okay, okay, good. Wi-Fi signal or maybe a satellite dish, and they can be used for signal to receive energy. Because that's what they look like and it's how they catch signal. Okay, okay, good. Wi-Fi antenna. The parabolic antenna. I think they are shaped like dishes because a curved surface with a cross-sectional shape of a parabola to direct radio waves. Wow, that's a really good one. Who wrote that one? Okay, okay, good. Okay, I see. Satellite dish send signals around the world. You misspelled the world. I think they get signal from the outside houses. Shape the signal. Shape to get the best signal. Okay, okay. So a lot of you guys making really good assumption, and they are really good guess, and that's good. That's good. So most of you guys mentioned the word signal. All right, most of you guys are saying that it's shaped like a dish because you are going to receive signals, whatever kind of signals, maybe radio or Wi-Fi or whatever. It's shaped like a dish because it can catch signals. So all of you guys are, correct. Some of you guys are more correct than the rest. And this is what we're going to talk about today. All right. So today we're talking about something new, or kind of new. At least this is a concept that you guys probably have never heard before, right? So this is, I think, the first time in Algebra 2 we are talking about something that you have not yet learned from Algebra 1. And just pay attention. All right. So get your journals, notebook, and take some notes. If you pay attention, it is really easy. All right. But if you if you're watching TV in the background, then it's going to be a problem. So pay attention, guys. All right. So today we'll be talking about focus and directrix. All right. Focus and directrix, and that is very much related to the satellite dish that we just talked about. All right. So focus and directrix. All right, so let's take a look at how a satellite dish works. So you don't have to write it down, okay, guys? You don't have to write it down, but I do want you to just listen up, all right? Listen up. So let's just say there is a satellite dish right here. And then if you pay attention, there's always a little thing in the middle right here, all right? So it doesn't matter what kind of satellite dish that you are looking at, you always have the dish, and then you have the little thing that kind of sticks out right here, like that. So this little thing, this is the signal receiver, all right? This is the signal receiver. So this is what picks up the signal, not the dish, all right? Not the dish. Little thing in the middle, this is what picks up signal, whatever kind of signal that you're trying to pick out, radio or Wi-Fi or whatever. So the thing in the middle is the signal receiver, but the problem is this thing is so tiny. All right, this thing is so tiny. So when you pick up signal, you're only going to pick it up from right here to right here. So every signal that coming from the outside, if this is within the distance right here, you pick it up. Everything out here, you're going to miss it. You're going to miss everything out here. So to solve this problem, people will put a dish right here. We'll put a dish that shapes like a ball. It shapes like a ball like this. So now you have a bigger surface area to cache whatever signals or waves that you want to cache. And if you pay attention, you are going from here to here. You have a much bigger range, bigger surface area to cache all the signals. All right, you have just a bigger surface area to catch all the signals, not just the tiny little bit in the middle right here. So that is why you have a little dish thing right here. So when whatever waves or whatever signal that is coming from the outside, let's just say you have radio signal that's coming from the outside like this, it will go like a straight line. It will hit the surface of the dish. It will hit the surface of the dish like this. Hit the surface of the dish, and then it will bounce back to the signal receiver. It will bounce back to the signal receiver. So in other words, the signal receiver is actually backward. It is actually backward. So the thing, it actually looks something like this, all right? So only this part right here, it receives the signal, not the outside, all right? It's actually backwards. So when you have signals coming from here, it will bounce back, go back to the signal receiver, and then you got your signal like this, all right? And then the cool thing about this is that it doesn't matter which angle, that the signal is coming from. It can be from out here. As long as it hits the dish, it will always bounce back to the signal receiver. Doesn't matter what the angle. It can be hitting right here on the side. It will go back to the signal receiver, or you can go really close to the middle. It will still bounce back to the signal receiver. Doesn't matter which angle. So that is the magic after behind the satellite dish. All right. So curvature of the dish, the curvature. I hope I spelled that right. So how curvy is the dish right here? The curvature is very specific. It's very specific, okay? Because if it's too flat, if it is really flat, and then the signal is going to miss signal receiver, and then it will just go out like that, like this. You'll miss it. Or if it's too pointy, if the curve is like too pointy like this, and it will also just bounce the other side, and then it will bounce back out like that. All right. So what I'm trying to say is the satellite dish right here, curvature is very specific. All right, very specific. So if you are, have one of these at home for, DirecTV or whatever, try not to mess with it. If you hit it really hard with a baseball bat or something, if there's a dent, and it doesn't pick up signal really well. All right, so that's kind of how a satellite dish works. Okay, this is how a satellite dish works. All right, so this is a another image just to better visualize what's going on. So you have whatever radio waves or signals or whatever, it hit the dish. It doesn't matter which spot that it hits the dish. As long as it hit the dish, it will bounce back to the signal receiver right here. All right, doesn't matter which spot it hit the dish. Doesn't matter which angle. It will always hit the receiver right here. So one thing I want you to keep in mind is that receiver right here is always inside of the dish. So let's just say this is a receiver. You will have the dish like this. Receiver is inside of the dish. This is very important. It looks like it's common sense, but I need you guys to memorize this. The receiver right here is inside of the dish. not the outside. You cannot have it the other way around. You cannot have the receiver like this, and then the dish is pointing out this way. You can't do it like that, all right? This doesn't work. So make sure you understand that the signal receiver is inside of the dish. All right, so moving on. So let's just try to carry this concept to what we are going to learn today, all right? So today we're going to learn about focus and directrix. All right, let me explain what exactly is focus and directrix. So let's just say you have a curve, all right? So I'm going to put the curve like maybe right here, like this. All right, you guys don't have to draw the graph, but I do want you to write down the definition, all right? I do want you to write down the definition. All right, so let's just say I have a curve right here. So I'm only looking at maybe this part right here, maybe just this part, not the whole thing. So this is the satellite dish we're talking about, all right? This curve right here, this is the satellite dish we're talking about. All right, inside the dish, I need a signal receiver. I need a signal receiver. So I'm going to put it maybe somewhere right here, somewhere right here. So this is the signal receiver. And we have a term for it. And the proper term for the signal receiver is focus, right? Where all the radio waves or whatever, energy, anything that you want to pick up, it will always bounce back after they hit the dish, bounce back and then hit the focus right here. So the focus right here is the signal receiver. All right, so in this example, the focus is located at -4 and 0. -4 and 0. All right, after that, in between the focus and the vertex of the graph, right here, in between the focus and the vertex of the graph, distance right here, we will call it focal length. The focal length. And we will use the letter P. We will use the letter P for the focal length. So on this particular example, P equals to 3 because it goes from right here to right here. So the distance between the vertex and the focus right here is the focal length. And in this case, P equals to 3. And then focal length can be positive or negative. Depends the orientation of the graph, all right? It depends on the orientation of the graph. If this is right side up, you got a positive. You got a positive because the graph is right side up. If the graph is, let's just say, upside down, like that, and the focal length is going to become negative, okay? So it depends on if the graph is right side up or upside down. All right, and then now I'm going to carry the focal length right here. I'm going to do the same thing. I'm going to go down 3 units. So the focal length from the focus to the vertex, I'm going to do the same focal length, but this time I'm going to go outside, all right? I will go outside of the curve by 3 units, focal length. I'm going to go outside right here, and then I'm going to draw a line that is perpendicular to the graph. I will draw a line that is perpendicular to the graph like this. all right, I will draw a line that is the same distance away from the vertex as the focus to the vertex, all right? So same distance, the focal length. I'm going to draw a line that is perpendicular to the graph, and I will call it the directrix. This is the directrix. So the directrix is the perpendicular line outside, all right? The keyword is outside. The keyword is outside. Outside of the curve of the parabola, same distance from the vertex and the focus. So you got to understand the focal length. One of them is here, the other one is here. They are the same, all right? They're the same length. So directrix in this example, y equals to -6. Y equals to -6. All right, so these are the three things that we just talked about, all right? We just talked about focus, which is the signal receiver, is inside the curve, all right? Signal receiver is inside the curve. And then we talked about the focal length, which is the distance from the vertex to the focus, all right? The distance from the vertex and the focus, that's the focal length. And then we talk about the directrix, which is a line that is outside of the curve, perpendicular to the curve. You have the same distance, right? You have the same distance away from the vertex. All right, so this whole setup, focus, focal length, directrix. So this setup works no matter which way the graph is pointing at, right? It doesn't matter too much about the orientation. You always have three things right here. So in other words, it doesn't matter which orientation is a curve. So the curve could be like this, right side up. Then now you have the focus in here. You have the directrix right here, all right? Or if the curve is upside down, you will have the focus right here in the inside. You will have the directrix right out here. Or it could be sideways. If the curve is sideways like this, you will have the focus right here inside the curve. You will have the directrix like this. So if it points to the right like this, now you have the focus inside right here. You have the directrix right here. All right, so it doesn't matter which orientation is a graph. Focus is inside, directrix is outside. All right, so far, I hope you guys are following. All right. So the good news is you don't need to know all three of them. If you know two of them, if you know the focus or vertex, you can find the directrix. All right. If you know the focus and the vertex, you can find the directrix. Or if you have directrix and vertex, you can find the focus. So what I'm trying to say is you only need to know two of them. If you know two of them, you can find the third one. So let's look at this example real fast, all right? Look at this example. I'm giving you the curve. The curve is right here. It is a sideway. It is a sideway parabola. And I'm also giving you the directrix. I'm giving you the directrix. And now I want you to find the focus. I want you to find the focus. So imagine this is the satellite dish. If the directrix outside, you need focus, the signal receiver, to be somewhere inside, all right? To be somewhere inside. So let's find the directrix first. Directrix right here. This is the line that goes from here to here. This line is x equals to 6. X equals to 6. That's the directrix. And then the focal length. Focal length is from here to right here. This is the focal length. So that means it goes from 3. It goes from 3 to 6. It goes from 3 to 6. That means P equals to 3. And then this thing right here is pointed to the left. Pointed to the left, you need a negative. All right, point to the left, you need a negative. If it points to the right, it becomes positive. So I will talk more about this in just a little bit. I will talk more about this. So now that you have the vertex right here, you have the vertex, you have the directrix. Now to find the focus, you have to go the same distance. You have to go the same distance, but this time around, you have to go inside the curve. You have to go inside the curve, and you have to go 3 units. You have to go inside the curve, and you have to go 3 units. That will get you right here. That will get you right here. So that would be your focus. So that means your focus happens at 0 and -2. 0 and -2. So out of these 3 things, all right, out of these 3 things, you only need to know 2. Because if you know 2 of them, you can figure out the last one. So every single problem you do, they will give you 2 pieces of information, all right? They will give you 2 pieces of information, and you have to figure out the third one so you can get the complete picture of how the graph looks like. All right, now I want you guys to give it a try. So check your understanding. I want you to find the focus and the directrix. Find the focus and the directrix. So I'm giving you the graph right here. The line is right here. I'm also giving you the directrix, which is right here. This is the directrix. So now you're going to have to find rest. All right, you have to find the rest. That means you need to find the focus. The directrix is already right here. And you also need to find the focal length. You need to find the focal length. So think about what is the focal length, and then use the focal length help you find the focus. Use the focal length to help you find the focus. All right, so, okay, good. All right, somebody got it done already. Good. That's it. All right, careful because the graph is not scaled properly, guys. The graph is not very scaled because this is a -1 right here. All right, this is a -1. So every unit that you see is actually half It's actually 0.5. So be very careful on the unit. It's not properly scaled. You guys label the focus as well. If anyone is stuck, at least label the location of the focus. All right, label location of the focus. All right, some of you guys are stuck. All right, we're not talking about x-intercept, guys. Don't give me the x-intercept. We are not talking about x-intercept. And then some of you guys did it really fast, but you make a really minor mistakes. All right, guys. So look at my screen. Look at my screen. Look at my screen. So I give you the line right here. That means you have the vertex. I'm also giving you the directrix. So let's put down whatever that we do know. All right. So we do know about the directrix. It's right there. So the directrix is right here. This is y equals to -2. All right. That one's super easy. And then the focal length. Focal length is from the vertex right here to the directrix right here. So the length right here, this is p equals to 1. P equals to 1. And the curve is a right side up curve. This curve is right side up. For right side up curve, P is going to be positive. All right. For a right side up curve, P is positive. And then the focus, you have to go inside the curve, and then go the same distance, P. So that means the focus is right here. This is 3 and 0. This is 3 and 0. All right, so I'm not asking for x-intercept. All right, so I know x-intercept happens right here and right here. These two are the x-intercept, but I'm not asking for the x-intercept this time. All right, so we are just looking at the focus. Just looking at the focus and the directrix and also the focal length. All right, so let's try one more. Let's try one more. All right, let's try one more. So give it a try. All right, I'm giving you this graph right here. I already give you the focus. All right, this time I'm giving you the focus. And then line itself tells you vertex. The line itself tells you the vertex. So now you have to find the focal length. You have to find the focal length. You also have to figure out where is the directrix. All right, where's the directrix? Does it go this way? Does it go that way? And how far away it is from the vertex? All right, how far away from the vertex. So go to pure deck and give it a try. So think about where is the directrix and how far away the directrix should be from the focus. And then pay attention at the units, guys. The units. So this is -5 right here. This is -3 right here. So they are not really properly scaled. So be very careful on the units. Or think about the focal length. So the focal length is the distance from the vertex, the focus, how far away it is. From right here to right here. How far away is the focus from the vertex? So just count, guys, just count. And then be very careful on the units. So if you guys are done and if you want to keep yourself anonymous, draw something on the screen. But if you don't mind your name being exposed, I will just call your name. All right, the green smiling face, I want you to look at right here, the green smiling face. Let me find your work right here. All right, watch very carefully, all right? Watch very carefully. So the focus I'm giving you, this is the focus. This is the focus. So you should be right here. You have the X and Y mixed up. It's the other way around. So X value goes first, all right? X value goes first. So that means this is actually -3 and then +4. all right, -3 and +4. And then after that, focal length. The focal length is from the vertex to focus right here. Distance from here to here. So P equals to 2, right? It goes from -5 to -3. So P equals to 2. And then the directrix, if you go another 2 units out here. So this is the directrix right here. So can you think about what number am I looking at? So what number am I looking at? So do you think you can fix it? All right, this one is good. This one's good. So think about the directrix. Oh, you even label the directrix. Right, it should be slightly further. All right, slightly further. So right here is the directrix. Right here, because from here to here, this is -5 to -3. So focal length is 2 units. And then directrix is from -5, you have to go another 2 units. All right, go another 2 units to the left. So I think the problem is graph is not really a properly scale. Yeah, so every 2 unit is 1. That's the problem. Maybe I should fix that. So like right here, -3, and then 2 units later you have -4. 2 units later, -5, and -6. So that means your the directrix should be right here, right here. This is a directrix. So this is 2 units away, 2 units away from the vertex, right? So all right, so -7 is what we need. This line is located on top of the x-axis. This line is located on top of the x-axis. So that means we need an x equals to -7. All right. We need x equals to -7. All right. So thank you for trying. I mean, this is the first time you guys are learning this. So if you make mistakes, it's perfectly okay. All right. It's not a problem at all. It takes practice. When I first learned this back in high school, I was so lost. Like it took me like 2 weeks just to learn these. So if you make some minor mistakes here and there, that's fine. Don't worry about it. As long as you guys give it a try, that's fine. All right, this one's good. Okay. Very good. Very good. Do you think you can label the directrix as well? Label the directrix. So I mean the numbers are good, but I still want you to, always, label everything. The focus is already given to you. You have the line right here, and then now if you can label the directrix. There you go. All right, good. That's good enough. Good. Perfect. Thank you. And then maybe label the directrix, and then the rest are it's good enough. All right, and then I'm also having a lot of you guys who are not trying. Come on, guys, just give it a try. All right, you will see a problem like this on the final exam, and the final exam is 2 weeks away. So just do yourself a favor. Just at least try out one of these problems. You really don't want to fail the final exam, guys. All right. So now this is something that I need you guys to copy it down. All right, you need to copy everything down. So here is the formula for a regular vertical graph. So whenever we have a vertical graph, as in is either right side up or upside down. So these are vertical graph. If you see the graph that looks like this, you will use this formula right here. So for any vertical graph that is pointing up or down, you will use this formula right here. So make sure you write it down. And then if you have a graph that is sideways, if you have a graph that is sideways, it means it's either pointing to the left or the right, all right? If it's either pointing to the left or right. If it's sideways and horizontal, you will use this formula right here. So it depends on if the graph is vertical or horizontal. You will use a different formula. And these two formula, they are very similar, all right? Very similar. So it's very easy to get mixed up. So if you try to rush a problem, there's a chance that you use the wrong formula. So be very careful on this, all right? They're so similar. The only difference is swap the x minus h and the y minus k. So everything is the same. It's just that the position of these two thingy right here, they are swapped, and everything else are the same. So just gotta be very careful. And then right here, unlike the vertex form, both the h and the k are opposite of what you think. Both h and the k is opposite of what you think. I will talk more about this later on, but I just want you to kind of keep this in mind, all right? Both the h and k are opposite of what you think. So remember way back when we talk about transformation, talk about transformation, how many units away from the origin, this is like maybe 5 units to the right, and then 1 unit to up, and something like that. And you have to when you write the equations out, this is opposite of what you think, right? The x position. But this time around, both of them is opposite of what you think. All right. So I will talk more about this in just a second. All right, and then the last part is the focal length. Focal length is p equals to 1/4 times the a. A, this is a typo, all right? This is a typo. The a is supposed to go under, with the 4, so like this. So 1/4a. So this is a typo. The a is supposed to go under. I should not have put it outside right here. The a goes under. And then p is positive. Focal length is positive when the graph is right side up or opens right. All right. When this is right side up or opens to the right, p is positive. And then p is negative when it is upside down or it opens to the left. All right. So p is either positive or negative. It depends on which way. It depends on the orientation of the graph. All right, so make sure you guys, copy these formulas down, especially right here and right here. So without these two, you are not going to be able to do any problems. All right, I'll give you guys another 30 seconds. Go ahead and finish copying this down. right, so let's look at one example problem. All right, we're going to do one of this example problem. All right, a parabola has a focus of 3 and 5. So let's find 3 and 5. Find it. So 3 and 5 is right here. 3 and then 5. All right. So this point right here, this is the focus. All right. So you have the focus, and we need one more pieces of information. And a directrix of x equals to -5. So x equals to -5. Let's find it. -5 is right here. X equals to -5 looks like this. This is the directrix. All right, you have the directrix, you have the focus. So that also gives you a clue. It gives you a clue that your graph has to be sideways and it opens right. It has to be sideways and it opens right because the focus, the signal receiver, needs to be inside the satellite dish. All right. The focus has to be inside the curve. And then the directrix has to be outside. So it tells you that your graph should be sideways and it opens right. Sideways and opens right. Which also gives you a clue that P is going to be positive. All right, P is going to be positive. So just 2 pieces of information, you already got so much out of it. All right, just because they give you focus and directrix, already get so much out of this. All right, so label what you know, figure out the orientation. So that we just finished. Good morning. So you know the graph is going to look something like this. This is a sideways parabola. And we will use the equation. So think about which one that we're going to use. There are 2 of them. One of them is for sideways. So we are going to use the one that is y minus k and then x minus h. We're going to use this formula right here. I'm going to write it up here on the top. We're going to need it later on. Square equals 4p and then x minus h. All right. So we're going to use this formula. Right, but we still want to get a better looking curve, right? We need to figure out the vertex and everything. All right, now I want you to look for the vertex. Look for the vertex. Determine the transformation, and then also find the focal length. Find focal length and the vertex. So focus is right here. This is the focus. And then the directrix is right here. We need to find midpoint, and that will be your vertex. Find the midpoint, that would be your vertex. So if this is -5, and then this is 3, midpoint is going to be right here. All right. This is the midpoint. That will be your vertex. That is your vertex. And then we also know the graph is going to look, it's going to go this way. And then the P focal length is either this or that. Doesn't matter. They're both the focal length. Doesn't matter. So just start counting. So P equals to 4. P equals to 4. This graph points to, it opens right, okay? It opens to the right. That means P is positive. Vertex is -1 and 5. -1 and 5. All right, now let's look at how many units is shifted left and right, up and down from the origin. So compared to the origin, you are 1 unit to the left. And then you are 5 units up. 1 unit to the left, 5 units up. And then they are, let me see, 1 unit to the left, 5 units up. All right, so the H is going to be +1. They are both opposite of what you see, all right? They are both opposite of what you see. So if you go 1 unit to the left, you need a +1. And then the K is 5 units up. It's also opposite of what you think. So this is a -5. -5. All right, now use the above information and plug them into the equations. All right, plug them into the equations. All right, so at this point, you don't really have to do anything. All you got to do is plug in numbers. All you have to do is plug in numbers. So I'm going to plug in the K, which is right here. So that means you need a -5 right here. And then you need the H right here. That means you need a +1 right here. And then you need the P. The P is 4. All right, now all you got to do is solve this part and then you are done. All right, solve this part and then you are done. So 4 times 4. 4 times 4 is 16. -5 +1. And this is your final answer. All right, this is your final answer. That's your final answer. It's the equation for this parabola, this curve right here. So let me just kind of clean it up a little bit. So your curve that looks like this sideways, you have the focus out here, you have the vertex right here, you have the directrix right here, and then the focal length is either one of these. All right, so one thing I do want to mention, the y right here and the x right here, you need to keep it as a letter. You need to keep the x and the y right here. These two, they have to remain a letter. All right. So don't try to find numbers to put them in here. All right. You have to keep it as a variable. You have to keep it as a letter. Because I want you to think about this. All right. I want you guys to think about this. Let's just say you have you know, a whatever quadratic functions, something like that, you know. So let's just say this is 3 units to the right, 4 units up. When you write the equation for this curve, this is what is it? 3 units to the right and then 4 units up. This is the equation for the curve. You gotta see that the y and the x stays a variable. All right, it remains a variable. Don't try to put numbers in. All right, we need the function. The definition of the function is you need a input and then you need the output. All right, you need to put in a number for x so that you can get the y, all right? So you don't put numbers in here. This is going to state a variable. So the same thing goes here. The x and the y, they have to stay a variable. Don't try to put the numbers in. All right, so let's try this problem right here, all right, right here. So check your understanding. A parabola has a vertex that is 7 and 2, and then a directrix that is y equals to 4. All right, so I'm giving you two pieces of information. I'm telling you that vertex is 7 and 2, directrix is y equals to 4. All right, now I want you to figure out which equations can represent this parabola. So find these two things, all right? Find the vertex, find the directrix. Figure out the last missing piece, which is the focus. We are missing focus. You have to find it. Find the focus. So use the vertex, use the directrix, label them, find the focus, and also the focal length, all right? Find the focus and focal length. All right, so go to Peer Deck and give it a try, guys. Can you guys go to Peer Deck and give it a try? Come on, guys, at least give it a try. Don't just sit there and do nothing, all right? So do me a favor, give it a try. Seven, 2. All right, so I see some of you guys label the vertex 7 and 2. 7 and 2 is right here. This is the vertex. That one is pretty doable. All right, now it seems like you guys are stuck on the directrix. And I'm guessing that you guys are thinking, should it be like this or should it be like that? All right, I think this is what you guys are thinking. So let me tell you what. If this is a y equals to 4, if this is a y equals to 4, you will go to the y-axis, and then find positive 4. All right, go to the y-axis and then find positive 4, which is right here. Right here. Yeah, it's hard to find, draw a straight line. All right. So if you see this is y equals to 4, you will go to y-axis, find positive 4, and then draw a line, all right? All right, and that would be your directrix. All right, so if you guys, stuck on that, that's fine, all right? It is okay, now that you guys are learning this, all right? So, practice makes perfect. Don't feel bad about this. All right, so now let me see. With the directrix, with the vertex, you should be good enough to figure out your graph is going to look something like this, right? And this is the only way, all right? Oh, wait, no, I'm sorry. I make a mistake, sorry. This is a vertex we're talking about. So the line is on the vertex like this. I'm sorry. This is how it looks like. I thought that was a focus. No. This is the vertex right here. And then you have directrix. All right. So it will look something like that. And then now we need the focal length. All right. Focal length is between the directrix and vertex right here. All right. So this thing is regular. It's an upside down. So P equals to count how many units between directrix and the focus. So this is 2 units. 2 units, and then this thing is upside down, all right? Upside down, that means you need a negative sign. So this thing is upside down. You need the focal length to be negative. All right, you need the focal length to be negative. All right, now do the same focal length, but this time you have to go inside the curve. The same focal length, this time go inside the curve and then find the focus. All right, so the focal length is 2 units. You have to go inside the curve 2 units, find focus. See if you guys can figure it out. Find the focus for me. At least label it. At least label it. If you guys are stuck, just label it. And then tell me the location of the focus, please. All right, so you're going from right here, the vertex, you have to go 2 units down because the focal length is 2, right? 2 units down, that will get you right here. That would be your focus. So this point right here, that is your focus. So the location of the focus. Oh, wait, hold up. I think the whole, yeah, hold up. This is 7 and 2, but I put 6 and 2. All right, sorry, my bad. This is 7 and 2. Equals 4, 7 and 2. Right here. This is the correct point. And then focus is right here. Focal length is right here, right here. All right, so the focus is 7 and 0. All right, now let's figure out how many units this shift left or right, up or down. All right, you gotta find out how many units did it shift left or right, up or down. So from the origin, it shift 7 units to the right. 7 units to the right. It shifted 7 units to the right. So right here, this is positive 7. And then this is opposite of what you think. So that means you need a negative 7 right here. And you may as well put it right here. It's going to be there. And then you are also going 2 units up. 2 units up. All right, so 2 units up, and this is opposite of what you think. So this is a -2. This is a -2 right here. Oh, for a regular curve, you are going to use x minus h. squared equals to 4p y minus k. So for a regular curve, you will need to use this formula. All right, so now let's plug in the numbers, all right? Plug in the numbers. I need the x and the y to stay a variable, all right? X and y, we need it for sure. X and y right here, we need it for sure. And then we will plug in the h and the k. So the h is -7, -7. The k is -2. And then the p focal length is -2 as well. All right, so the last part is solve this and then you are done. All right, solve this and then you are done. You guys write the final answer. Write the final answer. All right, all right, all right. So I help you guys quite a bit on this one. Let's do one more, all right? Let's do one more. Let's do one more, and then, hey, all right, let's do one more. All right, this is the last one, all right? This is the last one. After this, you guys are done. So let's do one more. This is the last one. So check your understanding. I'm giving you two pieces of information. Here's a vertex. Here is the focus. So right away, find them and then label it, all right? Find them and then label it. Use the two to find any missing information. Use these two things, find whatever's missing. Figure out the orientation. Is it regular, up and down? Or is it sideways, left and right? Yeah, so why don't you guys draw something on the screen right away so I can maybe help you guys out if you guys are stuck. So draw something on the screen and then, if you guys are stuck, I'll give you guys help. So give it a try. All right, guys, go to Peer Deck, give it a try. The red exclamation mark. Check the P again. All right, check the P. The number is correct. The sign is incorrect because this thing is opens left. If it opens left, P will be negative. If this thing is opening left, P will be negative. So that means okay, -1. Hey, you change the final answer as well. So if that is negative, that means your final answer, something has to be negative. Something has to be negative. All right, good. That's it. You got it. All right, guys, go to Pure Deck, work on this problem. Give it a try, guys. Give it a try. All right, let me go over the answers. Vertex is -4, -2, -4, -2. This is the vertex. Focus is -5, -2. So your graph should look something like that. You will have a directrix that is right here. So sideways, P is -1. Directrix is X equals to -3. You are looking at 4 units to the left, and then 2 units down. All right, so that means -1 And then right here, you need y plus 2 and then x plus 4. Negative 4 right here, x plus 4, y plus 2. All right, that's your final answer. All right, so that's it for today. Go to the hub and get your homework. All right, so your homework is right here. So go to plans. Go to week of December 7, right here. Week of December 7. Focus and directrix. Your homework should be right here. Focus and directrix. So download the homework on your laptop and then work on the homework assignment. All right. Download your laptop, work on this homework assignment. All right, so that's it for today. I will see you guys again on Wednesday. All right, I'll see you guys on Wednesday. All right, you guys are dismissed.